guys, today's video is on unit rate and graphs of proportional relationships. Today's date is November 7th and the page number is page 58. Please make sure your date and your page number match in your notebook what I have here. If they don't, make it match. Figure out where you counted wrong or where you went wrong and make it match so that in 8 weeks when you have another notebook check, you don't lose points on it. Our objective for the day is I can calculate a unit rate and I can find the unit rate simply by looking at a graph of a proportional relationship. Unit rates, let's talk about those first. A unit rate, and this is once again, don't you love math definitions? A unit rate is a ratio in which the denominator is 1. Okay, in real world speak, if I have a car and I drive 120 miles in 2 hours, I am going 60 miles per hour, right? You guys are familiar with that, miles per hour. Well, it's 60 miles per 1 hour. Okay, it's not 60 miles per 10 hours or 60 miles per 30 hours. It's just 60 miles per hour per 1 hour. So that is a unit rate. 60 over 1 is a ratio in which the denominator is 1. So let's look at a couple examples. Our first example is all about a monkey eating some bananas. So a monkey eats 12 bananas in 3 minutes. And we want to find out what his unit rate is for eating bananas. Okay, there's a word that you need to be really familiar with here, guys, and it's per, okay? This monkey eats 12 bananas per 3 minutes, so in 3 minutes. And we want to find out the number of bananas per minute, so per 1 minute. That's our unit rate. If he eats 12 bananas in 3 minutes, that's our ratio. We need to simplify this. 12 and 3 can both be divided by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. So his unit rate is 4 bananas per, that very important word, per minute. Okay? Per really means division, guys. Okay? And if you think about it, that makes sense. If I'm dealing with a ratio, 60 miles per hour, 12 bananas per 3 minutes, what you do with that is take your 12 and divide it, a fraction bar is division, by 3 minutes. Okay, so let's go through another example because it's kind of confusing until you get the hang of it. This next example, make sure you're writing all of this down, guys, everything I've written. I use 15 pounds of cheese to make 6 pizzas. How many pounds of cheese are on each pizza? That each means on 1 pizza. So that is a unit rate question. If I start out with 15 pounds of cheese and I make 6 pizzas, I need to figure out how much cheese goes on 1 pizza. That's a question mark. Okay? So to do that, I can first try simplifying. 15 and 6 can both be divided by 3, so that's 5 over 2. But that's still not a fraction with a denominator of 1, and that's what I need. Here is where the fact that per means division comes in really handy. 5 pounds of cheese per every 2 pizzas, I have to do 5 divided by 2. And your arch nemesis comes back to haunt you again because this is long division. How many times does 2 go into 5? It goes in twice. Then I multiply 2 times 2 to get 4. Subtract to get 1. I don't have anything to bring down, so I add a decimal point and a 0 and bring that down. And 2 goes into 10 evenly 5 times. That's my decimal point. 5 times 2 is 10. I subtract them to get 0, and that means I'm done. So the unit rate here, 5 divided by 2, is 2.5. So we can kind of interpret that as there are 2.5 pounds of cheese per pizza. Okay, that is our unit rate. All right, let's take a look at some examples of graphs of proportional relationships, and we're going to find unit rate on this graph. This is going to go on page 59. Once again, it is November 7th. Don't put the date that you watch the video, put the date November 7th in case you decide to do it early or you don't do it on time. And put a heading on this page, unit rates on a graph. Okay, so we've talked about unit rate and how unit rate is going to be a fraction with 1 as the denominator. So maybe there are 10 apples for every 5 pies. My unit rate would be 2 apples per 1 pie. This 1 is really important here, guys. Let's take a look at a graph. A little review. A graph, the x-axis is the one that goes left to right. The y-axis goes up and down. I want you to label all of the things that I'm labeling. And in a proportional relationship, when it's graphed, it is going to go through the origin. Label that. And it has to be a straight line. If it's not a straight line, it is not a proportional relationship. Remember that from Monday's lesson. Now this graph is a graph of distance versus time. So that's used in physics a lot, actually, how far something goes in a certain amount of time. So you can see on our x-axis that time is the label for the x-axis. Just covered up something that I need. Hang on. There you go. And that our y-axis is a measurement of distance. When we find a unit rate on a graph, it's as simple as finding the 1 on the x-axis and moving it straight up until you hit the graph, right? I've hit the line, the graph of my proportional relationship, and then going straight over until I hit my y-axis. So when I do that, I go up from 1 until I hit my line, and then I go over to the y-axis, and it lands me at 5. That means that my unit rate for this proportional relationship is 5. Our distance is measured in meters per time, which is in actually seconds squared. Okay, that's what that means. S to the second squared. So our unit rate is 5 meters per second squared. Okay, and that's all information we got just from looking at a graph. Let's look at one more example. This is another distance, this time in miles versus time in hours here. And let's say you're going on a car ride, right? A trip somewhere. And we want to find the unit rate for how fast we have been going. Once again, we have our graph passing through the origin. Our graph is a straight line. Those all tell us it is a proportional relationship. We have our x-axis, which is hours, and we have our y-axis, which is miles. Unit rate. We are going to find the 1 on our x-axis. We are going to draw a straight line up. That's almost straight, sorry. And a straight line over. And that lands us at, as soon as I fix it, at 50, okay? So our unit rate for this car trip that we've taken is 50 miles per, fraction bar is per, and then our x1 is hours. So 50 miles per hour is your unit rate for this road trip, okay? Now, I just have to show you this. I can't resist it. This is a lovely little geometry connection for you, and I think it is just so nifty. In geometry, we deal with circles. You don't have to write this one down, guys, and please don't skip ahead. Just actually watch this. Circumference and diameter. Circumference is the distance around a circle. Diameter is the distance across the circle. And this is a graph that shows us the relationship between the diameter of a circle and the circumference. So somebody could have had a bunch of circles, measured the distance across, measured the circumference, and then put them all on this graph just to see what happens. As you can see, it goes through my origin. It is a straight line. And if I find my unit rate here, 1 would be about here. Okay? I can take a straight line up the graph, and then a straight line over. And you can see that that line hits around 3. And in fact, it hits exactly at 3.14 ... That, guys, is pi. That's how people find pi. That's how they discovered it. They looked at a whole bunch of circles, did some calculations, and saw that the unit rate, okay, between the diameter and the circumference is 3.14. I know I get excited about math. Just deal with it. Your reflection question for today, I want you to look at this graph and I want you to tell me what the unit rate is for this proportional relationship. And I want you to make sure to include the unit. So we've been doing things like miles per hour. We've been doing things like meters per second squared. I want you to find the unit rate, including the unit, for this graph right here. All right, bye-bye. Bye-bye.